When we use this partial fractions method, when the function to be integrated is of the form f of x by g of x, where both fx and gx are polynomials. Fx and gx are both polynomials. Okay, then there are two possibilities. That is, degree of fx polynomial f of x is less than degree of g of x, or it can be greater than degree of fx can be greater than degree of g of x. If it is less than degree of gx, it is called a proper rational function. Otherwise, the degree of f of x is greater than degree of g of x, it is called improper rational function. Okay, now if it is a proper rational function, we can decompose or split it into simple rational functions by this method of partial fraction. Okay, but if degree of f of x is greater than degree of g of x, that is, if it is an improper rational function, what is to be done? We have to make it as a proper rational function. What is to be done? Divide f of x by g of x. When you divide, you will get a quotient, remainder. Okay, so then you rewrite this improper rational function f of x by g of x as quotient plus that remainder you are getting divided by this divisor g of x. So this r of x by g of x will be a proper rational function. So after converting it into proper rational function, we can integrate or we can split it into simple rational functions by the different methods of partial fraction. So we are going to discuss the different possibilities of this f of x by g of x. There are four different types. So the first type is the proper rational function is in this particular format, px plus q by, it is the denominator consists of distinct linear factors. X plus a and x minus b are they are distinct factors as well as they are linear factors. In that case, we can decompose it into two simple rational functions like using this a by first factor plus b by second factor x minus b. After decomposing or splitting into these two simple rational functions, we can easily integrate it. And second type is integral px plus q by repeated linear factor, maybe x minus a repeated 2 times or 3 times x minus a whole cube. So the decomposition will be, we can split it into a by the first power plus b by x minus a whole square plus c by x minus a whole cube, which can be easily integrated. And the third category is, it can be a combination of both. That means px square plus maybe qx plus r by one linear factor or one repeated factor and one linear factor like this. Then we can write it as a by x minus a. For the repeated factor, it is like a by x minus a plus b by x minus a whole square. And for the third factor, this distinct linear factor c by x plus b. And finally, if we have in the denominator, there is a quadratic factor which cannot be factorized, or we can say it is a reducible quadratic factor. We cannot reduce this into linear factor. In that case, the partial fraction will be a by, as we did earlier, a by the first linear factor plus, for the next one it will be some bx plus c by that quadratic factor x square plus bx plus c. So there are four types under partial fractions. So by looking at the denominator, you can check under which category it comes. For example, if you want to integrate some x by x minus 1 into x plus 2 dx. So the two conditions are satisfied. What are the conditions? It is a proper rational function. Degree of fx, numerator is 1. Degree of the denominator is 2. X minus 1 into x minus x plus 2. So degree is 2. So it's a proper rational function. And it consists of distinct linear factors. So what we can do is we take that proper rational function here. X by x minus 1 into x plus 2 will be splitted into two. The first type, a by x minus 1 plus b by x plus 2. And we come back to this and we have to find out a and b. We will come back to that later. So we have decomposed the whole function x by x plus 1 into x plus 2 as this. So this integral is equal to first a by x minus 1 dx plus b by x plus 2 dx. And you know a and b are constants. So a into what is integral 1 by x minus 1. It is log mod x minus 1 plus b into 1 integral 1 by x plus 2 log mod x plus 2 plus c, the constant of integration. This is the answer, but we have to replace what is a, find out a and b from this. So let us take the LCM. So it is a into x plus 2 plus b into x minus 1 by x minus 1 into x plus 2. So that we can say that being the denominator same, we can equate the numerators. X is equal to a into x plus 2 plus b into x minus 1. By giving values for x or equating the coefficients on both sides, we can find out the values of a and b. Like if you put x equal to minus 2, this will be 0. So x becomes minus 2. Here minus 2 minus 1, negative 3b, which gives you b is equal to 2 by 3. If you put x is equal to 1, this factor becomes 0. So 1 is equal to 3a, which gives you the value of a is equal to 1 by 3. Let us come back and write a is 1 by 3 log mod x minus 1 plus 2 by 3 log mod x plus 2 plus 3. So we got the final answer. So we have integrated. Even the denominator consists of distinct linear factors. Okay, then let us do one example where we have a second category. Maybe it can be some 2x minus 3 by x minus 2 whole square dx. So it's a proper rational function with repeated linear factors. Okay, so what is that? It can be, we will go and we will put it into partial fractions. 2x minus 3 by x minus 2 whole square is equal to a by x minus 2 plus b by x minus 2 whole square. Okay, so this is the same as integral a by x minus 2, a will be taken outside, 1 by x minus 2 dx plus b into integral 1 by x minus 2 whole square dx. So as we did earlier, it is a log mod x minus 2 plus b into what is this? This is 1 by x plus b, x minus 2 raised to minus 2. So it is x minus 2 raised to minus 2 plus 1, minus 1 by minus 1 plus c. We have to find out a and b as we did earlier. 2x minus 3 is equal to a into x minus 2 plus b. Putting x is equal to 2, we are getting b. 2 to 4 minus 3, 1 is equal to b. And if you put x is equal to 0, any values can be given. If we put x is equal to 0, minus 3 is equal to minus 2a plus b, where b is 1. So minus 2a is equal to minus 3 minus 1 minus 4. So a is equal to 2. So you are coming back a is to 2 log mod x minus 2 minus b minus 1 by x minus 2 plus c. That is the second one. In the third type, there is a repeated linear factor and a distinct linear factor. For example, x by x minus 1 whole square into x plus 2 dx. So we have seen it's a proper rational function and it comes under the third category. So you take the function and we split it into a by x minus 1 plus b by x minus 1 whole square plus c by x plus 2. Okay, so we have x is equal to a into x minus 1 into x plus 2 plus b into x plus 2 plus c into x minus 1 whole square. By giving values for x, you are getting the value of a as 2 by 9 and b as 1 by 3, c as negative 2 by 9. Okay, coming back, this is equal to a by, so this is the same as a by 2 by 9 into integral 1 by x minus 1 dx plus b by plus 1 by 3 into integral 1 by x minus 1 whole square dx plus c by minus 2 by 9 into integral 1 by x plus 2 dx. So you have 2 by 9 log mod x minus 1 plus 1 by 3 into x minus 1 raised to minus 1 by minus 1. So minus 1 by 3 x minus 1 minus 2 by 9 log mod x plus 2 plus c. If you want, you can combine these two using the rules of logarithm. You can say that is 2 by 9 log mod x minus 1 by x plus 2 minus 1 by 3 into x minus 1 plus c. So that is the third type. And finally, we have the fourth type where the denominator consists of irreducible quadratic factor. Look at this x square plus 1. It is a quadratic factor which cannot be reduced into linear factors. So in that case, what we will do? It is, we take the function 1 by x into x square plus 1. We solve it into partial fractions. It is like a by, first one is x is a linear factor. Second one is a quadratic factor. So bx plus c by x square plus 1. So that you are getting 1 is equal to a into x square plus 1 plus x into bx plus c. Giving values or equating the coefficients, you are getting the values of a as 1, b as minus 1 and c is 0. So coming back, this is equal to a by x, that is integral 1 by x dx plus integral bx plus c minus x by x square plus 1 dx. So integral of 1 by x is log mod x, and you know this is minus 1 by 2 into 2x by x square plus 1, which is f dash by x. So log mod x square plus 1 plus c. So we have discussed the four different types of under partial fractions.